So continuing with lesson 5.1, fundamental identities in college trigonometry. This is 5.1b. We're in example 2. And what they're asking us to do with example 2 is express cosine of x in terms of tangent of x. So we've got the cosine of x, and they don't want the answer written as the cosine of x. They want us to write it as if it, instead of cosine, and they want us to write it in tangent. All right, now, if that's the case, we're going to have to, it's kind of like doing unit multipliers where you start out with miles, and they want you to convert that to centimeters. So you're going from something like miles to centimeters, and there's got to be a point in there to relate miles to centimeters, and one of the things you do is you end up finding out that there's 2.54 centimeters in 1 inch. Convert from the English system to the metric, you have to have a conversion crossover here in order to get into the metric over here that you're going. It's the same thing with these trig things, is we're trying to find out if there's some kind of commonality between cosine of x and tangent of x, and there's not. So what we're going to do is we're going to see if the cosine of x and the tangent of x have something in common with each other. So if we look at the identities that we have up here, we have a tangent that's related to secant, and do I have any? Oh, right here. I have secant that's related to cosine. So the secant is going to be my crossover, my thing that's going to bring both my cosine and tangent together. So I've got it in cosine. I need to switch it to tangent. In order to do that, I'm going to take my cosine, switch it to secant, and then put it over here and switch my secant to tangent. So I'm kind of going a roundabout way because cosine and tangent don't relate to each other, so I find another trig function that they both relate to that I can use as my crossover. So that's what I'm doing in example 2. They don't do very well in explaining what they're doing there, but that's the direction they're going. So I am going to write my secant as tangent squared theta plus 1 equals secant squared theta. All right. Now look what happens if let's see if I can erase. No, it's not going to let me erase. Let's just get that out of here. Alright, let's see what happens if I make these reciprocals. If I put a 1 over there, because look what I've got. 1 over secant is the inverse, or is the reciprocal of 1 over cosine. So this right here, now let me get rid of this right here is going to be the same as cosine squared of theta. Okay, remember, when you have those, so secant of theta equals 1 over cosine of theta, but if I put that as a fraction and cross multiply, I get 1 equals cosine theta times secant of theta. If I divide this by secant, I've got cosecant of theta equals 1 over secant. So even though secant equals that, cosine equals that, and that's what I've got here. So instead of writing this, and that's why I put a 1 above these, is because now I've got a reciprocal of the cosine. Now I'm switching this around to instead of having this here, I'm going to get the cosine squared of theta because they're equal to the same thing. So all that work just in order to get rid of secant and get myself over to cosine. Okay, because I'm trying to express my cosine in terms of tangent. Well, right now I've got cosine squared in terms of tangent, and I've got to keep going. So, what am I going to do here? Let's clean this up. I'm going to erase this and rewrite it, and I'm going to get rid of this mess right there. Okay, so that looks nicer. Alright, so I'm trying to find the cosine. So in order to find the cosine, I'm going to have to take the square root of both sides. And that's plus or minus. And so this becomes cosine squared theta equals plus or minus square root of 1 over 1 plus tangent squared theta. Okay, so I just kind of tried to rewrite this top one here without the radical sign and tried to make it a little neater. Alright, so that's what I've got. Okay, so let's see. I can take the square root of 1 and get 1. So then I end up with plus or minus 1 over square root of 1 plus tangent squared theta equals cosine squared theta. Okay, starting to look a little neater. Now I've got a radical down here. I cannot have a radical in the denominator, so I need to multiply the top and bottom by this radical here. So let's do that and see if we can move this out of here. Alright, so we'll move that up there. Okay, so here we go. Plus or minus 1 over square root of 1 plus tangent squared theta times okay. That takes the square roots off the bottom. That's all we are doing. And we've got plus or minus 1 times the square root of 1 plus tangent squared theta on the top. And we are done. We just set this whole thing equal to the cosine. Alright? Alright, so this is example 3. This is the last one. And they're telling us to take this expression, sine or tangent of theta plus cotangent of theta, and they want to rewrite it so that it's in terms of sine theta and cosine of theta. So they don't want it to say cotangent and tangent, they want it to say sine and cosine. So that's what we're going to do with this one here. So let's see if we can do that. Well, again, let's see what we know about tangent and cotangent. Well, I do know, according to my handy-dandy little chart here, that tangent is sine over cosine. Well, they want us to rewrite this in sine and cosine, so that's cool. Here they give us cotangent, cosine, and sine. So both of these are written in sine and cosine. So let's replace tangent of theta with sine of theta over cosine of theta. And let's rewrite the cotangent as the cosine of theta over the sine of theta. Okay, so we just got rid of those. Now, we've done what we were asked to do, but the only problem we have is we've got two fractions here, and we need to add those two fractions. And if you remember right, when you add fractions, you have to common denominators. And the way I teach this, and this is why, I look at this denominator, and I look at this one, and it's like, okay, what do I have over here that I'm missing here? Well, this has a sine of theta, so I need one over here. So I'm going to put a sine of theta here, and I multiply the top and bottom both by the sine of theta. Okay, so this one is this one, and I multiply top and bottom by the sine of theta. Alright, now let's look over here. I've got a sine, but I don't have a cosine, so I'm going to multiply the top and bottom by the cosine of theta. And I've got already have my cosine of theta over sine of theta. Okay, so sine times sine is sine squared theta. And cosine plus cosine, or cosine times cosine is cosine squared theta. And I put them both over cosine of theta, sine of theta. Okay, so all I did was simplified those. But one more thing before we're done. Notice I have sine squared of theta plus cosine squared of theta. I have sine squared of theta plus I have a 1 there, so I'm not even done yet. I can put a 1 up there, and this all goes away. And then I've got my cosine of theta, sine of theta, and I'm done with that one. So that's it for the lecture on lesson 5.1.